All right, so this is Math 2, Unit 6.3, Similarity Properties. And we have three properties that we're going to use throughout this unit. Okay, one is called the side splitter. The second one is called the similar right triangles. And the third one is the angle bisectors. And each of these bring up some pretty special characteristics of similar triangles. All right, let's start with the side splitter. Well, the side splitter says that if line segment DE and line segment AC are parallel, so let's write that down first. If we can say line segment DE is parallel to line segment AC, then we can say that line segment BD over line segment DA is equal to line segment BE over line segment EC. All right, well, what does that mean? Well, if these two lines are parallel, DE and AC, what we basically have is two similar triangles. So if these two line segments are parallel, what we know is if we take the ratio of BD over DA, it will equal the ratio of BE to EC every time. All right, and what I say when I do this is I say BD over DA will equal BE over AC. What I'm doing here is showing you I can draw lines to show the ratios. BD over DA equals BE over EC. And the reason I do that is I want to show you there's actually more ways to get these ratios correct than there are to get them wrong. Because the other ratio we could also do is BD over BE equals DA over EC. And what I'm saying here in this one is BD over BE equals DA over EC. And if I draw arrows again, I'm saying BD over BE equals DA over EC. And so what I'm trying to show you is when you're setting up your ratio and proportions, draw arrows, and as long as those arrows are going the same direction and don't cross, it will work. Okay? All right. So let's go on and go to our next thing here. Oh, there is actually, I almost forgot, there is one other that we can also do. We can do the inverse. So we can say if we know that BA over DA, so now we're saying the whole side over the short side equals BE. No, I'm sorry, this is wrong. It's BC over EC. So if we say BA over DA equals BC over BE, then we know that DE is parallel to AC. So this is the inverse. Here we say if the two line segments are parallel, then we know these two ratios will work. Here we're saying if we know this ratio works, then we know the lines are parallel. So we're just basically working backwards. Okay, so that's called the side splitter, and we're going to get some practice on that in a minute. All right, now the next one we want to talk about is the similar right triangles. If you look at this, how many right triangles do you see? Well, hopefully you see three. You see ABD, this little one, ABD. Then you see the middle-sized one, which is BCD. And then, of course, you hopefully see the big one, which is ABC. So what we want to do is we want to redraw all these triangles, and I'm going to draw them like this. I'm going to take ADB, draw ADB. This is ADB, and here we can see D is the right triangle here. This is 90, so that means this guy is 90 as well. Now the middle size one is right here, so I'm going to draw that one, and that one obviously is a little bit bigger. And that one is BDC, so BDC. And finally, we have the largest one of all, which this one we actually have to flip over, so it's ABC. Okay, and what you have to realize is if we did an extended ratio, AD over BD over AB equals DB over DC over BC, which would equal AB over BC over AC. All three of the corresponding parts, the ratios of them would all be congruent. So what we're basically saying here, what I just said, is that triangle ABD is similar to triangle, I said ABD, so BCD, which is similar to triangle ACB. ABD is similar to BCD, which is similar to ACB. Okay, and we're going to use this quite a bit because remember, we know these are all corresponding sides. So we can use them to solve different measurements, and we'll do that in a minute. And then you will remember we did that yesterday on worksheet 6.2. And I kept saying, well, you're going to learn about this. Well, here it is. When we have three right triangles like this, we know all three are similar. And basically what it comes from is a right triangle where a vertical was drawn from the right angle straight down perpendicular. This is called a perpendicular bisector. Okay, so the third one we have is the angle bisector. And that's when we take a triangle ABC, and out of one of the vertices we draw a line segment that bisects that angle. Okay, angle bisector. Angle B is bisected by BD. Okay, so we'll say if BD is an angle bisector, then BA over BC should equal AD over CD. Okay, let's take a look at it. So we're saying if BD is an angle bisector, then BA over BC should equal AD over CD. And if I were to draw arrows, I would say BA over BC, and I would draw the arrows this way. BA over BC should equal AD over DC. Okay? Arrows are going the same direction, and they're not crossing each other. But the other one we could do is BA over AD equals BC over CD. Let's take a look at this one. Here we're saying, I'll basically draw the arrows this way. BA over AD, so we could draw the arrows this way. BA over AD equals BC over DC. So again, they're going the same direction, they're not crossing. And of course, we're going to get lots of practice in all three of these. Okay, well, let's go on and do some examples. Let's start off with the side splitter, okay? How do we recognize a side splitter problem? Well, these two guys, these two line segments are parallel. That's the key. All right, we want to solve for x. So I'm going to show you two ways to set it up, and then we'll just solve one of them. I like to do the side splitter this way, although you don't have to. So that would be x over 14 equals 15 over 12. Okay, do you see how I drew the arrows in the same direction? Or, of course, we could do it this way. X over 15 equals 14 over 12. And hopefully you'll notice, look at, when we cross multiply here, x times 12 is 12x. Same thing here. And here we go 14 times 15, and here we go 14 times 15. Okay, and what is that, 210? Okay. All right, so now we'll divide both sides by 12. And we end up with x equals, I should have a calculator here, 17.5. I hate when they start you out with decimals, but that's okay. And you can see if we put 17.5, look at 17.5 is bigger than 14, and 15 is bigger than 12. So at least if we look at it real quickly, we can see it generally makes sense. Okay, now this is a good example. Now, if the entire length is 55 and this much is 45, then we should realize that that side is 10. All right, setting up our side splitter again. X over 10 equals 36 over 45. And remember, we do have the option of going this way. X over 36 equals 10 over 45. Okay, that's the last time I'm going to do both. I just want to show you there's actually more ways to get it right than there are to get it wrong. As long as your arrows that you're drawing don't cross, you're in good shape. And as long as they're going the same direction. You can see these two are both going left to right, left to right. Here, this one is going down, and this one is going down. Now, again, you'll notice when we cross multiply, x times 45 is 45x, and 10 times 36, or 36 times 10 is 360. Okay? Now we divide both sides by 45, and we get x equals 6, or actually say 0.67. We'll round it off to 0.67. Again, I wish they hadn't done that, but you can see that 10 times 4.5 would get you 45, right? And wait a minute, I'm sorry, that is not right. What am I doing here? Wait a minute. That's why calculators aren't always the best, because sometimes you just take the answer for granted. That's 8. I'm sorry, I didn't clear my calculator well enough. X equals 8. Okay, and you can see that 8 times 4.5 would give you 36. 8 times 4 is 32, and half of 8 is 36. Okay. Moving on. All right, so now what do you see? You see we have the angle bisector, okay? And here we have 18 and 30, and we have 12, and this whole thing is x. So this is where it gets a little tricky. The whole thing is x, and this much is 12. So this much here is x minus 12. Let's just make up a number. Let's say x is 20, okay? If this number is 20, and this much is 12, well then 20 minus 12 would be 8. If this side was 30, if the whole length was 30, and this much would be 12, this much would be 30 minus 12, okay, or 18. So hopefully you can see why that works. And now we're ready to do our angle bisector. And again, we can set it up any of two ways. We could go 12 over x minus 12 equals 18 over 30. I like the most direct approach. So to me, it looks like 12 over 18. I'll put this right here. 12 over 18 equals x minus 12 over 30. Okay, the nice thing about doing it this way, we can always reduce a ratio. So 6 goes into 12 twice, and 6 goes into 18 3 times. Now when we cross multiply, we go 3 times x minus 12, or 3x minus 36, equals 2 times 30, which is 60. All right, now I'll add 36 to both sides, and I get 3x equals 96. Divide both sides by 3, and I'll write it up here. I get x equals 32. Okay, let's go on. We got an angle bisector, and I'm going to take the easiest route. I always like to start with the variable, though, so I'm going to go 36 over x equals 40 over 54. I cross multiply. X times 40 is 40x equals, let's get my calculator out, make sure I'm doing the right thing here. Clear it, and 36 times 54 is 1,940. And now I will divide that by 40, because we'll divide both sides by 40. And let me do that one more time. Boy, I'm not having much luck with the calculator. I don't like using calculators. I like to do the work in my head. I think it's good practice. But, yep, x equals 48.5. Okay, so that is the side splitter and the angle bisector. Let's do some more here. A couple more challenging ones. Okay, and remember when we're doing these notes, I'm going to do every single problem. You don't have to do every single problem if you're feeling pretty confident, but I think it's good practice. Okay, so we have parallel sides, so we can say, I like to always put the variable on top. So I go x over 27 equals 7 over 6. We cross multiply, we get 6x equals, so 9, carry the 4, 189. I'll divide both sides by 6, and we get x equals, what do we get, 31.5. Okay, parallel sides again, so this is a side splitter. Well, I got x's in both, so I'm going to go 6 over x minus 1 equals 21 over 3x plus 1. Cross multiply. 6 times 3x is 18x. 6 times 1 is 6. And that equals 21 times x minus 21. All right. Oops, forgot my x. Be careful about that. Did that yesterday as well. So I'm going to subtract 18x from both sides. If you always subtract the smaller variable, you'll always get positive. So we get 6 equals 21 minus 18 is 3x minus 21. We add 21 to both sides, and I get 27 equals 3x. Divide both sides by 3, and we get x equals 9. Okay? All right. Moving on. And you can always check this work. 9 minus 1 is 8, so that guy is 8. And 3 times 9 is 27, plus 1 is 28. All right. So 6 is to 8. That's when reduced, it's 3/4, isn't it? Well, 21 is to 28 when reduced is 3/4 as well. All right. Just trying to show you those ratios work. If you want to check them out, do a little checking when you're done to make sure you got the right answer. It's always a good idea to check your work. All right, so what do we got going here? We've got 45 and 27, right? So if we go 45 minus 27, we've got 18. Okay, and they didn't give us any help here. So I think this is a bit of a mistake. I think they meant to give us this here. Let's see how that works out. I'm not sure. Okay, so if this is an angle bisector, we know that 3x minus 9 over 27 should equal x plus 11 over 18. All right, so now we're just getting tricky here, just making it a little tougher on you. Let's make that a little bigger. Maybe it'll help you guys out a bit. So when we cross multiply, definitely going to need your calculators here to make sure you're doing this. All right, so when we cross multiply, looks like we'll go 3 times 18, which is 30, 54x. And then minus 18 times 9 is 162. And I didn't leave myself enough room, but that equals 27x plus 270, 297. All right, so if I subtract 27 from this side and I subtract 27 from that side, I end up with, what do I end up with? 27x minus 162 equals 297. I'll add 162 to both sides, and we get 27x equals, what do we get? A 9, a 5, and a 4. So 459, we divide both sides by 27. We get x equals, let's see here, 459 divided by 27 is 17. Okay, now let's do a couple more. Let's just go ahead and finish them out, power through. So we got an angle bisector, so I know x over 18 will equal 45 over 20. Nice thing about this one is we can reduce. 5 goes into 24 times and 5 goes into 45 9 times. So now when we cross multiply, we get x times 4, which is 4x. And 9 times 18, well, 9 times 10 is 90, and 9 times 8 is 72, so it's 162. Divide both sides by 4, and we get x equals, well, 4 goes into 16 4 times, and it goes into 2 0 times, so 40.2, okay, 40.5, excuse me. All right, last two. All right, again, angle bisector. So if this much is x and this whole thing is 40, then this must be 40 minus x. You're going to have to do this on the test. Let's just pick a number for x. Let's say x is 10. If the whole thing is 40 and this is 10, then this must be 40 minus 10 or 30. All right, so I like to put my x first. So x over 30 equals 40 minus x over 45. Now, some of you might have just rather put lines there and went 30 over x equals 45 over 40 minus x. Same thing, it's just flipped over. All right, so we cross multiply. X times 45 is 45x. And 30 times 40, well, that's 3 times 4 is 12 plus 2 zeros. And 30, we get 30x, negative 30x. Okay, 30 times negative x is negative 30x. I add 30x to both sides, and I end up with what? 75x equals 1200. And we divide both sides by 75. Okay, so we get x equals, what do we get? 4 times 4 is 16. Okay. All right, last one. I'm going to redraw this down here because remember we have 3 right triangles. We have one, the small one, the medium one, and the big one. So I'm going to redraw them like this. I kind of always get in the habit of drawing them the same way. Don't have to do that, but I just always draw them this way. And so this small side is x. So as I go, I put all the information in. So the small side is x and the longer side is 8. Okay, now the bigger one, I'm going to make it purposely a little bigger. And they just have to be right triangles. They don't have to be dimensionally accurate. Okay, now on this one, this is this one right here. So we know this shorter side of it is 8 and the longer side is 14. Okay, this triangle here, the short leg is 8, the long leg is 14. On the small triangle, the short leg is 8 and the short leg is X and the long leg is 8. And then we draw our biggest triangle of all. Okay, that's a right triangle. And we're talking about this guy. So this is the short leg. We don't know anything about the short leg. We don't know anything about the long leg, but we do know the hypotenuse is X plus 14. Okay, so see, now we can look, and what do we know? All right, well, we know these two guys are in a relationship, and those two guys are in a relationship. We're looking for X. So we're going to say X over 8 equals 8 over 14. X over 8 equals X over 8 equals 8 over 14. When we cross multiply, we get 14x equals 64. We divide both sides by 14, and we get 64 divided by 14 is 4.57. That doesn't look too nice. X equals 4.57. Okay. All right, and there you are, 6.3 notes. Your job is to complete 6.3 odds.